Hello, ladies and gentlemen. What I'm going to be doing today is walking you through the introduction to this unit, which is over chemical reactions. So, again, what we're doing in this unit is called mastery-based learning, which means I'm going to be testing you on the end. You have to be able to know this material. So I'm going to go through a few things that you need to know right now. So what you're going to need to know is you need to know that chemical reactions are represented by chemical equations. And I'm going to show you how to write those here in a second. Chemical equations are a way for us to write what atoms and molecules are doing. They're going to be rearranging, they're going to be switching around. So we need a way to keep track of that, and that's what chemical equations do. You're also going to need to know the difference between elements and compounds. So make sure you know the difference between those. Also, you're going to need to know how to write a chemical equation. Hopefully by the end of this lesson, you will know exactly how to write a chemical equation. So, to get started, really what I just want to show you is chemical reactions are really everywhere. Whenever we cook, there's some type of chemical reaction going on. Respiration, that's what pretty much we do in order to keep our bodies going. We have respiration that happens inside our bodies. In hair dyes, if any of you dye your hair, there is some type of chemical reaction going on. Autofuel, okay, that's actually a type of reaction called combustion, but we're burning a fuel that's creating energy and heat, and we're using that energy and heat in order to propel our cars somewhere. Here's how you usually know when a reaction takes place. If you see a color change, so something changes color, chances are a reaction happened. A precipitate formation. What a precipitate is a precipitate is actually when you mix two liquids together and a solid forms. So you see how, kind of here, how this black compound is forming. Sorry about that color, but here, let's see if we can go here. Right here, see how that black compound is forming? That's actually called a precipitate. Next thing is a gas formation. So whenever you see bubbling or something like that, chances are there's a reaction happening, or an odor. That's something that is a way that you know a reaction happened. And the last two things are a temperature change or a change in acidity is another way to know that a reaction happened. So now we're really going to get into what you really need to know in order to master this material is how to write a chemical equation. So we observe chemical reactions. I just told you kind of some ways that we know reactions happen. But what we have is we have to have a way to write this kind of in a shorter way. So here's our reaction. The reaction that I'm going to be talking about is actually right here. And I'm actually kind of leaving off that last section because I'll talk to you about that here in a second. But what it says is it says solid sodium combines with chlorine gas to make solid sodium chloride. So I don't know what actually happened here, but there should be an arrow right here. I'll explain to you what the arrows and the plus signs and stuff like that means. But really what's happening is what we're doing is all you need to do is look out for elements and for compounds. So elements are things that are listed by themselves. So notice how here sodium is listed by itself. So all you really need to do in order to get this sodium and make sure you get this right here is just go to your periodic table. You find, okay, you know sodium, so you just go to the periodic table, you find the symbol for sodium, it's Na, and you write that down. Then it says combines. Combines is a word that usually means addition. Okay, we're combining, we're putting two things together. So we're combining sodium and chlorine gas. Notice how chlorine is listed by itself. That is also an element. So we're going to write that by itself. Now, I have put together a list for you that tells you when to list something as diatomic. So this right here should actually be written Cl2. I'm sorry that this number got made large, but really it should be a subscript, how I've written it below. But chlorine is what we would call a diatomic element, meaning when it's listed by itself in a chemical reaction description like it is here, we actually write it Cl2. Then to make sodium chloride. So sodium chloride right there, that's our compound, and that is what is going right here. Now, how we get sodium chloride is actually, we need to make sure and do something that's called crisscross our charges, which we did in our naming and writing compounds unit. So what we do is we actually write Na, it has a +1 charge. We write Cl, it has a -1 charge. And we actually crisscross those, which means I'm going to take the 1 here, I'm going to write it down here. I'm going to take the 1 here, I'm going to drop the charges, meaning I'm going to drop the +1 and the -1. I'm going to write Na1, Cl1, but like we learned, you do not need to include the 1s. So you would just write NaCl, and that's what we've included right there. Okay? So chemical equations are different from numerical equations, and how they're different is they have a reactant plus a product, or sorry, reactant A plus reactant B goes to a product, and there should be an arrow right there. So the reactants are used up in forming the product. Very similar to like if you were making cookies or something, you know, you need flour and you need sugar and you need chocolate chips and you need milk and all that stuff. Those are the reactants, and they're used up. All that stuff is used up to make our cookies. What the arrow does is it shows us the direction of the reaction. So whenever I draw an arrow going one direction, that means that all my stuff on this side is coming together to make what's on this side. And that's just how I draw it. So this is telling me, the arrow tells me, hey, it's going to the right. I'm going to read this left to right. Now there's some symbols that we need to know. A plus sign, what that does is that separates more than one reactant or product. So whenever it says something like sodium reacts with chlorine, that tells me that I'm going to write my symbol for sodium. It reacts, so that's usually when I'm going to use that plus sign to separate the sodium and the chlorine, right, like I did right there. Also an arrow. What an arrow does is an arrow separates reactants from products. So I need to make sure to put that in the middle. We've used arrows before. We used them in like nuclear chemistry. Remember that unit where we were drawing arrows? And it indicates the direction of the reaction and also separates reactants from products. So here's an example, and I'm going to show you how we just walk through this and what we're going to get. So what we're looking for is we're looking for elements and compounds, and we're going to write those down. So aluminum reacts with HCl to produce hydrogen and aluminum chloride. So here's something I'm going to need to write down. My aluminum, it reacts with HCl. I'm going to need to write that down. Produce is important, and hydrogen and aluminum chloride are important. So my aluminum, I'm going to write, because it's listed by itself, I'm going to find it on the periodic table. Its symbol's Al. Now it says it reacts. That means I'm going to have my plus sign, and it's reacting with HCl. Now to produce. To produce is giving me a hint that, hey, I'm not talking about my reactants anymore. Now I'm talking about my products, which means now it's time to put in my arrow, and it's going to produce hydrogen. And hydrogen is one of those diatomic elements. So notice how hydrogen is listed by itself. Okay? So over here on this side, right here, hydrogen was listed in HCl. Notice how it doesn't have a 2 there. But now that hydrogen is listed by itself, it is diatomic, which means H2. So I'm going to put it in here as H2. And aluminum chloride. Now, whenever we have a compound listed, we have to crisscross the charges. So aluminum's charge is +3, chlorine's charge is -1. So I'm going to take this charge, I'm going to write it down on the aluminum as a subscript. I'm going to take this charge, write it down on chlorine as a subscript. And I'm going to reduce if I can. On this one, I do not have to reduce. So my correct formula, I'm going to drop the charges, I'm going to drop the plus sign, I'm going to drop the minus sign. And actually, because there's a 1 that's going to be on Al, I don't even have to write it. So I'm going to write AlCl3. And you have to do that every time. Every time you write a chemical equation, you have to make sure that when you're given a compound, notice how this is a compound, this is an element because compounds have more than one substance, elements have just a single element, just hydrogen. So that's one thing you're going to have to make sure you remember. And we're going to do one more. So notice how now we have iron 2 chloride reacts with calcium oxide to produce, that's important, iron 2 oxide and calcium chloride. So let's start writing. Now, iron symbol is Fe, and it has a +2 charge. And it is with chlorine. So remember, anytime I write a formula, I have to write the charges, and then I have to crisscross them. So I'm going to crisscross that charge, write down like that. So iron chloride, actually, its formula is actually FeCl2. Then it's reacting with calcium. So because it's reacting with calcium chloride, or calcium oxide, excuse me, what I'm going to do is I'm going to write a plus sign, and then I'm going to take my calcium oxide. I'm actually going to do this up here. Write their symbols and charges, and then crisscross them. So I'm going to bring the -2 down here, the +2 down here, and that's going to be Ca2O2. But remember, if we can reduce them, we do. And what we do is we'll just divide them both by 2, which means they're both going to be 1, because 2 divided by 2 is 1. So this is going to be CaO. And then it's going to produce, so that means I draw my arrow. Now it's going to be iron 2 oxide. So iron 2 oxide is Fe +2 and O -2. I'm going to crisscross those charges, and they're actually going to cancel out just like they did with my calcium oxide. They're both 2's, so I can reduce them. So it's just going to produce FeO plus, and then my calcium chloride is Ca with a +2 charge, Cl with a -1 charge. And remember, how I'm getting these charges is I'm not just making them up out of thin air. I'm getting iron's charge from this right here. It's telling me the charge, iron 2. And then I'm getting chlorine and calcium's charge from the periodic table, what column they're in. So chlorine is in column 7A, and so it has a -1 charge. Oxygen is in column 6A, it has a -2 charge. That's where I'm getting these. I'm getting these charges. Calcium's in 2A, it has a +2 charge. That's where I'm getting all this stuff. So back to writing my calcium chloride, I crisscross my charges, and I get CaCl2. So there's my formula. I've now written my chemical formula. So thanks for listening. I hope you found this helpful and you know a little bit more about how to write chemical equations and also the difference between an element and a compound. So thank you for listening.